Will proceed in innovative approach in calculus. Innovative approach in calculus. What are we trying to do? Innovative approach in calculus. There we are trying to bring the steps, the innovation, the new thing, the new idea that we have brought in rather than it is available in the book or it is available at the internet. So that is the concept behind the innovative approach in calculus. Okay, in that sense, we are in discussion for the product rule. Product rule. So in calculus, integral calculus is considered as the most basic calculus. Calculus started from integration, and integration is nothing but multiplication. Means multiplication we are trying to find out from a calculating the area of a shape. If someone is saying what is multiplication of two items where one item is x and another item is dependent upon x and that is also x. One side of I would rephrase multiplication of two items is nothing but repeated addition, one side. Multiplication of two items. Multiplication of two items. It has two sides. One side is addition and another side is area. How I can achieve multiplication of an two items? One side is repeated addition and one side is the calculation of area. Two ways I can have multiplication. Repeated addition, if I am saying repeated addition typically works with the numerical value. 2, 3 into 2, 3 added twice, 4 into 5, 4 added 5 times, 4 plus 4 plus 4, that is 4 into 5. Okay, that is called multiplication. What are other ways to calculate the multiplication? Now 4 into 5. Take a rectangle. One side is 4 and one side is 5. Now take a small rectangle whose length and width is 1 by 1. Length and width is 1 by 1. So area is 1. Now arrange into 4 into 5 big rectangle, that a small rectangle or a square, whatever it is. Okay, 4 into 5, 4 is the width and height is 5. 4 will come along the x-axis, again 4, again 4, that is 5 rows. In that sense, if someone is counting number of squares that he has placed, it will become a area of the rectangle. Area of the rectangle is nothing but how many 1 by 1 square fits in there. Very simple. What is area of 4 into 5 rectangle? Take a small square whose width and height is 1 by 1. So area is 1. Basic area is 1. Now put into 4 into 5 rectangle and see how many those squares are coming. That is the area of a rectangle. That is nothing but multiplication of two sides. That way also we calculate the multiplication. Okay, it is raining outside and I'm partially wet only. Okay, I hope light is less. Anyway, now that is the concept that width into height is the area. Then width into height is the area, or area is width into height. If width and height are two part of a multiplication, calculating the area gives the multiplication result. Okay, I believe it is completely all right. What is the area of a triangle? Area of a triangle is, if this is a triangle, what is what is area of a triangle? If this is one side of a triangle, this is other side of it, this is other side of a triangle. One side of a triangle, other side of a triangle. Okay, and then this is the perpendicular other side, third side of a triangle. So this is a triangle. If this is a triangle, what is the area of a triangle? If I complete this, then it becomes a rectangle. Means for this rectangle, this triangle is half. If this is perpendicular of triangle, same perpendicular I take here and draw a parallel line to this line, then this becomes a rectangle and this triangle's area is half of the rectangle. What is the area of a triangle? So area of a triangle is nothing but if I put one by one square inside the triangle everywhere and count it, then it is the area of a triangle. It is difficult to put one in the corner area. So put one in the rectangle, count it and make it half. That is the area of the triangle. So area of the multiplication can be calculated calculating the area of a rectangle. Mind it, area of the rectangle. Okay, area of the rectangle give the multiplication of kind of two operand. This is what I can say, two operand. So that gives the, so if it is rectangle, then counting the squares, it gives the area. Count the square in the rectangle, make it half, it becomes the area of the triangle. Okay, now that is the situation. Now, but we know that area of any two side, I have repeated this many times. Area of any two side, area means a shape which has two sides. That is called area. Volume means a shape which has three sides. Length means a shape which has one side, like line, curve, whatever it is. It is a length. Area means which has two sides. So if I'm trying to calculate the area, then actually more or less we are trying to multiply two sides of the area. That is the concept. Now, if someone says what is 2 into x, then x I can take on x-axis and 2 is the height. Then 2 into x is nothing but x on one side, that is a variable, and height is fixed. Area of that variable is the multiplication. If that is the multiplication is nothing but computation of the area. What about multiplication of two times, where two operand where one is x and another is variation upon x? This is also variation upon x only. One is x and one is 5. One is 5 into x to the power 0. 1 is 5 into x to the power 0. What about another is 5 into x? If this is x, another is 5 into x. When x is 0, here, then height is also 0. Otherwise, height grows the way x is growing, 5 times of it. Okay. Now, when x equal to 10, at that time height is 50. Okay. When x is 10, height is 50. In that sense, what is the area? Area is nothing but if I am trying to multiply two items, then indirectly we are calculating the area. If we are calculating the area, indirectly we are trying to multiply two items. Other way is also true. Okay, if that is the scenario, one side is x, another side is fx, what is the area? If I tell you what is the area, then someone can say that is nothing but multiplication of two sides. So one side is x, another side is 5x, then area is x into 5x. But it is not true. Area is, if you multiply x into 5x, it will give something like rectangular area. Multiplication of two items, simple multiplication of two sides, give the area of a rectangle. Okay, in that sense, what is the area of a triangle? Or then, okay, I'll proceed. Okay, so one side is x, another side is 5x. One side is x, another side is 5x. It forms a triangle. If I calculate this area, somehow if I know how to calculate the area, then I can say that I have found the multiplication of these two sides. Okay, so other way, Finding the multiplication is nothing but finding the area. If I somehow able to calculate the area, then I am able to find the multiplication of two sides. That is also equally true. We are landing up into from numerical science purely into algebra. In that sense, now question is arising how I can find area of any shape. If I find area of any shape, then in a abstract way, I can say that these are the two sides of the area. Okay. So if if it is x and it is 5, constant 5, the area is 5 into x. In calculus term, it is called 5 into dx. Why you use dx? Because the 5 into x means two sides of rectangle. Not necessarily that two sides always be rectangle. It can be triangle, it can be sinusoidal, but whatever, it has two sides. Area means two sides. One side is x and other side is function over x. This is what calculus way of calculating the area. If I say I am calculating 5 into x, you are not calculating 5 into x. Actually x, or you are calculating 5 into 4. 5 into 4. Then as per the calculus algebra, 4 is x-axis and 5 is y-axis. So 4 is x-axis, 5 is y-axis. 4 into 5 or 5 into 4. 5 is y-axis, 4 is x-axis. In that sense, 4 is along x-axis, that is independent component. 5 is along y-axis, that is dependent component. So, so in calculus, we say 5 into 4. 5 into 4. 4 is along x-axis, or I can replace 4 with x. 4 with x. Now, I am saying 5 into x. 5 into x is the area of rectangle. Someone would say, no, I am saying 5 into 4. I am also saying 5 into 4 only. 5 into x, where x equal to 4. Is it alright? Yeah, it's alright. Okay, okay. Now what is the area? 5 into x is the area. Now, x is variable and 5 is dependent upon it. 5 is 5 into x to the power 0. So 5 is called function over x and x is independent component. Now what is the area? Function over x, that is the y component, and x, that is the x component. If you multiply, it gives the area. But it gives a straightforward area. Only one area is a rectangle. Only when area is rectangle, then only it gives the straightforward multiplication would give the area. Otherwise, straightforward multiplication will not give the area. Like one side fx is 5x instead of constant 5 means everywhere you take any x, the height will be 5 always. So it will be like this. The line we draw is like this, parallel line to the x-axis, that is y. So area is underneath it, that is x into height. Now if height is varying as per the x, then area, certainly it is not width by height, because height is dependent upon x. In that case, what is the area? Someone would say, I have mucked up that area is multiplication of two sides. One side is x, another side is 5x, then 5x into x is the area. But certainly it is not the area. 5x into x is not the area, because 5x into x is 5x square. It talks about a rectangle. Whose one side is 5x and other side is x, but it is not a rectangle. Okay. So if someone say algebra, typical algebra, what is 5x into x? Then it is 5x square. How you draw it? Then someone would draw x as width and 5x as height. If you take width x equal to 10, then height is 50, and dependent upon x. But if you say calculus algebra, then one is dependent component and another is independent component. So algebra would draw 5 into 5x as a rectangle, whereas calculus would draw 5x and 5x. One is x-axis independent component and 5x is dependent component function over x. Then it will be typically a triangle where x is growing and 5x is also growing in height. What is the area? So calculus would say the area is the area of a triangle. That is nothing but 5x squared by 2. Okay. Now, as per the algebra, if there is an area, it is multiplication of two sides. Calculus is also saying it is multiplication of two sides only. Then 5x into x is not the multiplication because it is a triangle. So it is 5x into dx. D comes into the picture, signifying it is calculus algebra. Calculus in algebra means one is dependent component and one is independent component. Calculus algebra works in this fashion. One is independent component, one is dependent component. If I say 5 into x, then independent component is x and dependent component is 5 into x to the power 0, which is a constant which does not vary if x is varying. In that sense, it forms a rectangle. But if independent component is x and dependent component is 5x, then dependent component, which is the height is varying and x is varying. Typically, it will not draw a rectangle. It will draw a triangle, whatever it is. If we are trying to find an area, then area is multiplication of two sides. Then two side is one side is height into other side is dx. Rather than x, it is dx. Dx means inside d, whatever is there, that is independent component. Whatever outside the d, that is integrand, is dependent component. This is the sign of multiplication of two sides of an area. I am trying to find area of a shape whose one side is x and other side is 5x. Then area is not 5x into x. Area is 5x into dx because it is not a rectangle. In that sense, some intelligence is required to find the actual area, actual multiplication. So this is the kind of called calculus. Anyway, this is one thing. So this is integral calculus. What about differential calculus? Differential calculus is opposite of integral calculus. If fx into dx is gx, then dgx by dx is fx. If I have dependent component as fx and independent component as x, then fx into dx gives the area. If I have that area in terms of dx, that may be an algebraic equation again, then dgx by dx would give the height again. If I have width and height, if I multiply width with the height, then it gives one area. Then differentiation of this area with the independent component or width gives the height back. Fx into dx, height into width, gives hx. Then dhx by dx, area by width again gives the height back, that is fx. That is anti-integration is differentiation. Anti-derivative is integration. That is not true. Okay, mathematically it is true, but it did not start from there. Anti-integration is differentiation. Means if I have calculated the area for which x-axis is the independent component, if I divide the area by x-axis, I get the height back. I get the function back. Function or y into x component is the area, then area by x is y back. That is differentiation. But how differentiation is meaningful in kind of a shape? If this is x-axis, and this is the area, this is the area curve. With fx dx, I have calculated gx. Consider I have calculated gx, or I have calculated hx. Consider hx. Fx dx gave me hx. And in terms of that, if this is x-axis and this is hx, this hx is a algebraic equation. This is the area curve. If this is hx and this is x, so if I say dhx by dx, it will give me fx back. Fx dx integration equal to hx. Hx is an algebra. It can be drawn like a curve. If this is the graph of the hx and this is x-axis, if I do differentiation of hx along the x-axis dhx by dx, it gives me fx back. Okay, in that scenario, if integration is calculation of the area, then what is differentiation? If I have hx equation and this is the x-axis, at any point x, what is hx? That is the height. At any point x plus 1, what is the height? That is hx plus 1, hx plus 1. This is hx plus 1, this is hx. If I subtract, I get the difference in the height that arises because of I have one unit change along x-axis. If at point x height is hx, at point x plus 1 height is hx plus 1 or h1x, then h1x minus hx is difference in the height that is achieved because we moved one unit along x-axis, dhx by dx. If I move one unit along x-axis, how many unit of change I see in hx, dhx by dx? That is actually differentiation as far as graphics is concerned. If this is hx, integration of hx along x-axis is the area underneath it. Differentiation is nothing but if I make one unit of change along x-axis, how many unit of change hx is making. At x, this is hx, at x plus 1, this is x, new h. New h, old h, if I subtract, what is the amount that is hx is growing if I grow one unit in x, dhx by dx. This is the exact representation of differentiation. If I move delta x along x-axis at point x, then dhx by dx is nothing but hx plus delta x minus hx, that is change in vertical, by delta x. Okay, so there are other way. Now this is differentiation. Now question is arising, if hx equal to fx into gx, the hx algebra consider it is multiplication of two separate function fx into gx, small f braces x braces close, fx gx. If I multiply two functions fx into gx, then what is dfx into gx by dx? So it is something like, if this is x-axis, then this is fx. There is another line that is gx, fx, gx. Now I have at any point x, this is the height of fx. At same point, gx has height this much. If I multiply fx into gx, now if I change x to x plus 1, then I see another height in gx. I see another height in fx and another height in gx. If I multiply these two heights, then whatever the multiplication comes, that is x plus 1, and on x-axis where point is x, at that time what is fx and what is gx? So these multiplication, if I subtract, whatever comes, divide by 1. One unit change along x-axis brings how many unit of change in the multiplication of fx into gx? That is product rule. So what is differentiation of fx into gx? That is fx dgx by dx plus gx plus dfx by dx. This is something that we are calculating many fundamentally we have used. So we will try one more fundamental post that I'll see if I can bring in one more. But whatever we are trying to do is amazing, thrilling, and it is completely our approach. fx gx, fx into gx. What is the differentiation of fx into gx? Is it really fx into dgx by dx plus gx into dfx by dx? This is the product rule. in differentiation. Okay, if I have two graphs fx and gx at point x, what is fx and gx? Multiply it, and at point x plus delta x, what is fx and gx? Again multiply it, and then subtract the height by delta x. That is dfx gx by dx. Now, now consider, now we will go to two dimension. We'll go to two dimension, three dimension. Consider this is x-axis and this is y-axis. X-axis, y-axis, z-axis. Now this is xy plane. This is x-axis. This is y-axis. In that sense, this is xy plane. Consider a, a surface, flat surface is kept on the xy plane. If it is kept on the xy plane, this is y-axis and this is x-axis. If I keep y constant, if I keep y constant and then move the x-axis, then at any point x1, this is x-axis. At on any point x1 on x-axis, how much I see the height has moved. That is the slope what we are seeing in the xz plane. This is xz plane. This is yz plane. This is y-axis. This is x-axis. This is our proof. Okay. In that sense, if I keep y-axis constant and move the x-axis along the x-axis at any point x equal to x1, at that point, what is the height? At any point x equal to x1, when it is sitting at the xy plane, then there is no height. But if I move it, then at point x equal to x1, what is the height? What is the height? That is whatever slope we are seeing, slope into x1 is the height. Okay, more slope is there, then at x1 height will be more. Less slope is there, then at x1 height will be less. If there is no slope, then at x there is no height. What is the slope? That is dz by dx. If it is a flat straight line, then simply I can say then every moment slope is same. At every moment slope is same. But if I have a sphere, if I have a sphere, if I have a sphere, then if I take tangent surface, then everywhere tangent surface is different. Means every point the slope is different. If this is a surface, a spherical surface, this is a spherical surface. In that sense, at any point, a spherical surface, at any point, if I draw a tangent surface, if I draw a tangent surface, then here the tangent surface is like this. Here tangent surface is parallel to xy plane. Here tangent surface is perpendicular to the xy plane. Every moment tangent surface is different. At every moment dz by dx is different. So if I take dz by dx plane, this is dz by dx, this is xz plane. Dz by dx, if I take, then in xz plane dz by dx is like this. There is no, at the top there is no dz by dx. There is no gradient. But if I move in xz plane, we can see dz by dx is changing because the tangent. Now dz by dx is completely, the slope is completely perpendicular, means infinite. Then dz by dx is negative, like that. Okay, if that, I mean dz by dx is positive, and then it becomes infinite, then dz by dx is negative, and it becomes 0. When it becomes 0, then dz by dx, in dz by dx, if I cut this, if I cut this xz plane, if I cut this in xz plane, there will be a circle. Okay, if I cut this, if I just cut in xz plane, then there will be a circle. Okay, in that circle actually we are trying this. Okay, if it dz by dx is reaching 0, means at that time this is parallel to the x-axis, or roughly I can say at that moment this plane is parallel to the xy plane. This is xy plane, x-axis, y-axis, z-axis, this is the origin. Okay, so that is the scenario. Now, now the question is arising that dz anytime what is z at point x equal to x1 dz by dx dz by dx into dz by dx dz by dx is constant if a surface is flat or x by z dz by dx into x1 that is the height we can see. If I keep this constant, if keep x-axis constant and move y-axis, then at any point y1, what is the height? dz by dy, dz by dy into y1. If I do both, first we move x-axis, then there is a height at x equal to x1. Then we keep the x-axis, right now I have kept the y fixed. Now keep x fixed and move again. Then z is growing again. What is z at y equal to y1? First x equal to x1, the height we achieved was dz by dx into x1 plus if I keep x constant and move only y, then dz by dy into y1. If I keep y constant, if I move x, then dz by dx into x1. If I first keep y constant and move like this, then keep x constant and move like this. What about the height at point x1, y1? Then I have to add both because first it lifted like this, then again it lifted like this twice. So it is nothing but dz by dx into x1 plus dz by dy into y1. Z equal to dz by dx into x1 plus dz by dy into y1. Or I can say at any point x comma y, at any point x comma y, z equal to dz by dx into x plus dz by dy into y. Okay, what is the equation of the surface at any point x, x1 comma y1? If this is the sphere centered at the origin, if this sphere is centered at the origin, then this is half of equator, half of this sphere is the xy plane. Top is top hemisphere and bottom is bottom hemisphere. And this is pierced and this is at center. In that sense, at any moment, what is the tangential surface equation? That is a question. At any moment, this is the tangential surface equation at the top. Here, 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 here. What is the tangential surface equation at any moment? What do you mean by any moment? Any moment means if I have xy plane, I take any point x comma y, and from that point, if I calculate fxy, that is the sphere equation, that is square root of a square minus x square minus y square, that is z. If I draw fxy, it is hitting one point on the surface for which below the point is x comma y. At any point x comma y, what is the tangential surface equation? That is z equal to dz by dx. dz by dx is calculated at point x comma y. Or at any point x1 y1, what is the surface equation? That is z equal to dz by dx calculated at x equal to x1 into x plus dz by dy. This dz by dy is calculated at y equal to y1 into y. This is the equation of the surface that is at the point x1 y1 comma fxy. Okay, if that is the case, now I know any point, if you give me any point alpha comma beta on x-axis where the height will be fxy, f alpha comma beta. If that is the case, then what is tangential surface equation at that point? That is z equal to, that is the tangential surface equation is dz by dx calculated at x equal to alpha into x plus dz by dy calculated at y equal to beta into y. This is the equation of surface at that point. If I know the equation of surface at that point, equation of the surface means z. If there is a surface at this point like this, I leave this. What is the equation of the surface? This is a flat line, right? Equation of surface is dz by dx calculated at that point because we are talking about a particular point on the surface. Particular point on the surface. Now, what will be delta z? Z equal to dz by dx calculated at point x equal to x1 into y into x plus dz by dy calculated at y equal to y1 into y. That is equation of z at that moment. Now, now consider this is the surface equation. This is the surface equation. I mean x equal to x1 and y equal to y1. This is the point x1 comma y1. This is z. Now consider that I move delta x along x-axis and delta y along y-axis. What are you talking about? I am talking about a new point, that is x1 plus delta x and y1 plus delta y. There is a new point. At that point, what is z? That is, if z is fxy function over x and y, then first point is f x1 comma y1. Another point is f x1 plus delta x comma y1 plus delta y. That is the another z. What is dz? What is gradient of z? How much z varied? When point is x1 comma y1, there is a z. Yes, there is a z. What is z? That is function over x1 and y1. What is that? If it is a sphere, the sphere equation is x square plus y square plus z square. True. Equal to a square. X square plus y square plus z square equal to a square, where a is the radius of the sphere. Then z equal to square root of a square minus x square minus y square. That is z. I know what is z. Okay, what is z at x1 y1? x1 y1, that is square root of a square minus x1 whole square minus y1 whole square. What is the height? That is the height. What is the height at another point where I move delta x from x1, delta y from y1? Then what is mu z? Mu z is the square root of a square minus x1 plus delta x whole square minus y1 plus delta y whole square. That is mu z. What is mu z? Consider mu z is z1. One is z and one is z1. How much difference I saw in z? How much difference I saw? That is called delta z. If z equal to dz by dy at y equal to y1 into, dz by dx at x equal to x1 into x plus dz by dy at y equal to y1 into y, what is delta z? Then delta z equal to dz by dx into delta x plus dz by dy into delta y. This is also called, we are trying to calculate a difference in z. Difference in z is nothing but dz by dx calculated at x equal to x1 into delta x plus dz by dy calculated at y equal to y1 into delta y. This equation, if you fulfill, that is the delta z. That much delta z we saw. Consider z is nothing but, what is z? For a sphere, z is the square root of a square minus x square minus y square. No. Our question arises, we want product rule, right? Let's consider z is multiplication of two functions, fx and gx. Z equal to fx and gx. What about then fx into gx? Fx into gx is nothing but dfx gx by dx into x plus dfx into gx by dy into y as per the fundamental. Then what about delta z? What about delta of dfx into gx? You are trying to calculate derivative. Yes, delta z means derivative. Then delta z, that is dfx into gx. This is our proof. This is not available in any of the book. dfx into gx. This is what I am trying. dfx into gx. That is delta z. Then that is equal to dz by dx. That is equivalent to dz by dx into delta x plus dz by dy into delta y. True, right? Now, if that is true, earlier we had z equal to dz by dx into x plus dz by dy into y. Delta z equal to dz by dx delta x plus dz by dy into delta y. Now z equal to fx into gx. Fx into gx. If fx into gx, now fx into gx, that is function, that is multiplication of that is a function over x, that is fx function over x, that is gx, multiplication of two items. Now here it is now z dz by dx. dz by dx. Okay, if that is the case, then it will be replaced by dfx into gx, because we have taken z equal to fx into gx, dfx into gx by dx, by dx x into delta x will be replaced by fx. Okay, I'll reiterate it. Z equal to, z is function over x and y, function over x and y. So it will be something like x into y, x square into y square, sine x, whatever. Z is function over x and y. If I say z equal to fx into gx, z is function over fx and gx. Z equal to fx into gx, we are trying to say z equal to is function over fx and gx. Z equal to dz by dx, that is dfx into gx by dfx into delta fx, plus dz by dy, dfx into gx by dgx into delta gx. Now dfx by dx, dfx into gx by dfx. This is nothing but partial derivative. It will come as gx, gx into delta fx, gx into delta fx. Delta fx means differentiation of fx, means dfxy by dx, gx into dfxy by dx, plus plus dfxy gx gx by dgx, fx into dgx. So derivative of or delta of fx into gx is nothing but gx delta fx plus fx delta gx. Someone can try. Amazing, right? Means we had formula where z is function over x and y. If that is the case, then dz by dx, that is first derivative with the first independent variable in xz plane, dz by dx, z equal to dz by dx into x plus dz by dy into y. Change in z, change in z is seen, change in z is seen when there is a delta change in x and delta change in y. Then dz, then delta z. How much delta z change? Delta z is nothing but dz by dx into delta x. Whatever delta x change in delta x that we saw, plus dz by dy into delta y. If these are happening at x equal to x1 and y equal to y1, this is what we saw. Delta z. Now z is a function of x and y. Consider z is function. Or if it is not understandable, then someone can take x equal z equal to x into y. Z equal to x into y. Now it is better. Z equal to x into y. Simple, right? Where x and y are independent to each other. If that is the case, then delta z or delta x into y equal to dz by dx. Z is x into y. dxy into x by dx. Since x, y are independent to each other, y will come out dx by dx 1. Y into delta x plus x into delta y. So delta of x into y equal to delta of x into y equal to y into delta x plus delta x into y. I am sorry. Delta of x into y equal to y into delta x plus x into delta y. Differentiation of x into y, if I consider x is function over u, that is fu, and y is function over u again, gu, fu, gu. So delta fu gu equal to y into delta x. Y is gu into delta fu plus fu delta gu. This is what we want with the product rule, right? So Amazing proof, right? This is, we don't need any approximation. Very concrete, very straightforward. Where is the problem is that it went into three dimensions. That no one expects that x and y I take two independent components and then we go in 3D. This is our proof. This you will not find in any of the book. That we find the kind of product rule through three-dimensional way. If time permits, next session we'll try to take more on it, or and if there is something else we'll try product rule proof in that fashion also. Okay, so that is the scenario. Please do support us. +91 is the India country code. 94831 60610. 94831 60610 is the telephone number. +91 is the India country code. Please do support.